Good afternoon, everyone, and welcome to our second session of the day, focused on active debris removal and in-orbit servicing. Richard Love and Tiago Soares. And also as rapporteur, we have Laura Alex Marco. So first, thank you to all of you to be here with us to talk about this important issue. So I would pass on the word for just a brief introduction about yourselves and then also your presentation on this topic. And so we can start with Ian Grosser. So Ian, you have the floor. Thank you.
Yes, hello everyone. I hope you can hear me. Can you confirm that you hear me?
We cannot hear you, Ian.
Well, we cannot hear.
I was able to hear you.
Oh, great. That's good. So I hope the rest also hears
Wait, I think it's my problem. I apologize. Please continue. Thank you.
No problem. Let me bring up my slides. Okay, I can maybe just start briefly introducing myself. My name is Jan Grosser. I'm working for the German Aerospace Center, in particular the Space Agency part. And can you see my slides?
Yes, we can. Yeah.
Ah, great. Okay, good. So my responsibility at the DLR Space Agency is to maintain the space debris mitigation requirements and to implement the requirements in every of our space projects. I would like to thank the host for this conference. I also already joined the first session with a lot of interesting talks and discussions, and I'm very honored to join this session here on active debris removal and in-orbit servicing. And what I like to present is how those topics, active debris removal and in-orbit servicing, can help us here at DLR to perform our space activities in a safe and sustainable manner. And that is for sure something that is of high priority for us here at the DLR Space Agency. So this slide here basically summarizes the major mitigation measures from DLR projects. And they should look familiar for you because they are actually derived from well-known standards and guidelines. So, of course, we want our projects not to generate space debris at all, not on purpose. And we have also very strict technical requirements on the accidental creation of space debris. And of course, we don't want to hit stuff in space, other spacecrafts or space debris and micrometeoroids, whatever is around. And of course, you cannot avoid any impact in space, in particular impacts with small objects. And in this case, we require the spacecraft to have a robust design to limit the consequences of such impacts. And you can hear me say that we don't want to launch grenades to space. Or to leave grenades in space. So if you finally complete your mission...
I'm sorry for interrupting you. Just to let you know that we are not seeing your slides moving. It's not in presentation mode, so we are still seeing the first slides.
Okay, so the title page?
Yes, exactly.
Okay, let me check. And this way, does it advance?
No, it is still on the title page.
I will reshare. Sorry for that. So I will just try to this. Okay, let me just give me an indication if you again see the slides.
Yes, I can see it. Yes, the first page.
Okay, the very first page.
Yes.
Okay.
It is not on presentation mode, so we can see the slides also on the left.
Okay, so that's an easy fix. And I think now you should only see the slides. Is that correct?
By now I can still see the full screen.
Okay, that's That's strange. I'm very sorry for this technical issues. So maybe, okay, I would just, okay, so second try, and let me, can you give me an indication if you now see my slides?
Now.
Okay,
It's perfect.
great.
Thank you very
So
much.
let's go ahead. So these are the major mitigation measures for DLR projects, and I stopped at the fourth bullet point. So after you complete your mission, you are requested to deplete any onboard stored energy to reduce the risk that this spacecraft actually explodes. And then we request you, of course, to limit the lifetime in precious orbital regions like the low Earth orbit region, the LEO regions, and of course also the geostationary orbit. And we don't want you to fall on someone's head, so you also have to take care for human casualty risk on ground. And if you have anything hazardous on your spacecraft, please do not dump this in a forest or in a water body. So you have to take care for anything on your satellite that can harm the Earth's environment and seafaring and airspace and so on and so forth. And now let's assume that we are the ones that can update the major mitigation requirements for DLR project. And let us think about how actually active debris removal and in-orbit service could help advance the mitigation measures. So this is what we actually do now. So how could possible future mitigation measures look like? And you already discovered the gaps in my list, so there is room for improvement. And I would like to start with what you do at the end of your mission. So as I said, you are requested to passivate the system to make it safe. But from experience, many of our, not all, but many of our satellite system at least partially work very good. And I think it's fair to use or to think about options, how to use systems that are in space that at least partially work, and to use it for a longer time, but of course in a safe way. So as an alternative to just deplete your satellite, let's think of the analogy of a car. So if your car runs out of fuel, or the charge in your battery drains, then you have two options. You could simply buy a new car, but there are other options like refueling or recharging your car. And I think that's also a valid question that you can ask yourself when using a satellite. And that is something that we study here at DLR for a longer time. And that basically means that we think about a new type of satellite in space that is designed to be maintained, that can be upgraded, that can be reused or even recycled in space. And this could create the opportunity to use stuff that you have in space and that works at least partially, that we can use for a longer time, and create therefore more sustainability. Okay, and I want to proceed with the next bullet in my list here. Imagine a situation where you have a car and that brakes on a highway, and the police officer is approaching you and says, okay, but don't let your car leave here for longer than 25 years. That's insane to think about a situation like this, but we tend to behave in space like this, and we are already discussing to change rules here. So basically, what you would do, you would call a tow truck and get rid of the car. And I think that this is also the situation that we should aim for in space. So the most famous 25-year rule in LEO that you most probably know. We are currently discussing this to prepare our satellites to be actively removed and from valuable orbits, and most probably directly after you complete your mission. Okay, so these are possible changes of our mitigation measures, and you see that therefore in-orbit servicing and also active debris removal can play an important role. So you could ask, why don't you make this right now? Good question. Glad that you ask. Unfortunately, we are not right there. I'm pretty sure that the next speakers, Bruno and Richard, can give us more details on this. At least we have already started to think about these topics and spend effort and money on development projects. One has to know that in-orbit servicing and active debris removal missions are exceptionally challenging and dangerous. You all know space is an unforgiving environment. Client objects may not be cooperative at all, or not even designed to be visited and maintained in space. And most important, in case of failure, you could easily end up in a situation where you have more debris than before. And there are more challenges, like legal challenges. You have to take care for of liability issues, who's responsible for stuff that is decades in orbit, and you even have delicate problems like export control. And for sure, you will not do anything in space like this without any proper consultation before, and that's all challenges that you have to resolve before you can do such a mission. And of course, there's also a need for standardization, and most obvious, you need to define interfaces, mechanical interfaces, electrical interfaces, and so on and so forth. But there's also the need to agree on terms and on guiding principles, on definitions like that, and also very important safety principles. And we as DLR, we have development projects going on. We have EU-funded European operations framework where we made a guidelines documents addressing all these issues, and we are very busy at ISO and IADC to develop, co-develop guidelines and standards for these topics. That's all from my side. Thank you.
Thank you very much, Ian, for this very insightful presentation. I think our moderator, Manuel Metz, it's already here. Hi, Manuel. Can you hear us? Can you talk?
Hi, and good afternoon. I hope you can hear me.
Yes, perfectly. Thank you very much, Manuel, for joining us. And I will now give the floor to you to continue this session. Thank you very much.
Yeah, thank you very much. Unfortunately, I had some technical problems, and I had to basically dismantle and mantle up completely again my setup. So this is also why you now see me in this frog perspective, because I have had to use my mobile phone. But thanks again, in the meantime, Jan, for your first presentation. And the next speaker on our list is Bruno Carvalho. With more than 18 years of experience in space industry, Bruno founded a company in UK in 2017, providing strategic business consultancy to the space market in Europe. And then he joined D-Orbit in the UK, and after that in Lisbon in June 2019, where he assumes responsibility over the Portuguese operation as a managing director of D-Orbit. So Bruno, please, the floor is yours.
Hi, hello. I hope you can hear me well. I'm just going to quickly share my screen. See if it works. Hope you can see it now. Thank you. Okay. Thank you for the introduction and for the invitation. I think following up on what Jens was saying, I'm just going to quickly present what D-Orbit is up to and on these themes and why we're going down the route we're going. And obviously, I think that the meat of this panel is going to be the discussion afterwards, which I hope can be fruitful. So the orbit was founded in 2011 with the vision of creating the first space logistics infrastructure to enable the $1 trillion space economy that everybody keeps talking about by the end of the decade and beyond, and obviously also sustain human expansion into Spain. And this has to be done in a safe and sustainable way. And by safe, we also obviously need to address the space debris issue, which relates to how we're going to mitigate that, how we're going to clean up after ourselves, and obviously then how to service the cars that, as Ian was saying earlier, are broken down in orbit. So that's part of the challenge. So the orbit, as I said, was founded in 2011 in Italy. We have offices in Portugal, UK, and the United States of America. We currently have 12 missions in orbit. We're going to launch our 13th the day after tomorrow. These are our transportation missions, which include hosted payloads as well as other assets that are deployed into their specific orbital slots. There are specific reasons why we went down the route of a transportation service. This enables us to create the technologies and use and leverage the technologies that are required to basically move around in orbit, to pinpoint orbital slots, to use those kind of technologies to then approach particularly the orbit servicing market, and obviously then the refueling stations, the recycling systems, and so on and so forth. So we are really addressing a bottleneck, which is basically the space, access to space, which is currently particularly for the Western markets, unfortunately, with the situation in Europe, in terms of Ariane 6 not being online and Vega having some issues, we're currently flying with Falcon 9, and the geopolitics of the whole situation. Although obviously this is a UN forum, does create issues with access to space. So we're trying to address that bottleneck in several ways. One being, as I mentioned before, the space transportation as a service and the space logistics as a service. So what brings us here today is the circular economy, which includes obviously all the aspects that are required to address a space mission, which will need to be done from design. So we need to plan, as Ian said in his presentation before, to address for the assets to be removed from the useful orbits, be it in GEO or LEO or MEO or whatever, so be removed from the highway, from the useful orbits, but then create the mechanisms and plan for what to do with those resources, which can be obviously brought down and burned out in the atmosphere, but could potentially be captured again and, melted, recycled, whatever. There are several interesting propositions to what to do. Although from the orbit's perspective, I think the main objective is to really mitigate the debris from happening in the first place. So I think we'll discuss this in a panel, but one of the issues with active space debris removal is the actual business case for that to happen and the cost versus benefit for it, let alone all the issues that Ian raised before and the challenges regarding legal aspects, liabilities, and so forth. So if I'm to fetch an object in orbit that is not mine, I need to obviously ask permission, and then each involves different countries potentially, and who takes responsibility for that last object once the vehicle is attached to the other one. So all these things are relevant. So the approach that the orbit is taking is to actually avoid the creation of debris by design, that so missions would be removed from orbit as soon as possible after the mission is ended. So we actually want to do it not just below the 25-year recommendation, but actually even below the 5-year recommendation that FCC is pushing forward, which, by the way, companies like SpaceX are currently imposing on their customers. So it's just quite interesting to see how that is flowing down in terms of the regulatory framework, and because we all see that this is an issue, and we need to protect our own environment in order to be able to operate it safely. So ideally, I'm going to really go quickly on this presentation, and this is my last slide, so that we can spark the discussion. So ideally, we want to achieve the in-space transportation. So what D-Orbit is doing today is to leverage the capabilities that we've been creating from the devices that would allow debris removal, the technology that we have in terms of the propulsion to move around in orbit, and then create the in-orbit servicing and waste management facilities, which would then include other aspects of a mission that we are working on, which includes things like robotics, different propulsion systems that are more capable, which would then evolve into something bigger. I think one of the big challenges that that I would say humanity faces when looking into orbital manufacturing and in-space transportation, particularly from a human scale, in terms of human transportation scale, if you want to go to the moon, go to Mars, is to scale up the structures that are built in space, and those need to be built in space, a bit like the ISS was built in space with different modules going different times. We will need to do it in space, but the question now is, how can we do it more efficient? And this is a perfect example of potential reusability of materials in space. So cleaning up space debris with and trying to reuse those materials. Then obviously there's a discussion, and I think it's outside of the scope of the session, but it's for us it's important, because I think we also need to understand how to bring materials either from asteroids or from the moon to build those structures. I think it's or we believe that it's unsustainable to just send all the materials up from Earth with the current economics on the launch capacity, even with the Starship. So we'll see what happens. But I think this is the basis for the discussion, and obviously there are follow-up questions, and I have other notes that I'm sure Manuel will poke me. So I'll stop sharing here.
Thank you very much, Bruno, for that very interesting presentation, and for providing us an industry perspective. So our next speaker on the list is Richard Lowe. Richard is the Director for Technical Services at the UK Satellite Application Catapult, which is an organization with a mission to innovate for a better world empowered by space. So Richard has more than 20 years of experience in the space sector, spanning various activities. He's now a fellow of the Royal Aeronautics Society and a member of the Society's special group on space. So Richard, the floor is yours.
Great, thank you very much. So I'll just share my slides. Okay, so hopefully you can see my slides. I'll press on. So thanks very much for inviting me to speak here. So and for the introduction. So I'll not cover too much of my own background there, but just say I'm the technical director for an organisation called the Satellite Applications Catapult here in the UK. Also the co-chair for our in-orbit and service manufacture working group within the UK Space Trade Association. If I can get my slides to move on, that would be lovely. Okay, great. So just a word or two about the Satellite Applications Catapult. So we are a not-for-profit organisation here in the UK. Our objective is to grow the space business and also to grow the positive effects of space for society. So when I talk about growing space business, that's not specifically the Satellite Applications Catapult itself. It's the whole commercial ecosystem that surrounds space and feeds that into society and benefit of people across the world. And so we theme that work that we do into a number of different areas. Sustainability is one of the core themes of our structuring there, along with connectivity and autonomy, both sort of central aspects of space benefits. So we really summarise that in the phrase that you heard just a moment ago during the introduction, to innovate for a better world empowered by space. And I think that captures quite well what the organisation is here to do. So, debris in orbit service and manufacture. So what I wanted to say really here was just draw a few comparisons, I suppose, to challenges we face in orbit debris and working safely in space, and challenges felt elsewhere in daily life. So, three things that I think we've all come to realise are not infinite, even if they were once felt to be so. The oceans of the Earth, the atmosphere of the Earth, and the space around the Earth that we're now operating in for scientific and commercial reasons. So, in orbit service and manufacture and active debris removal are two areas which are very closely coupled. The whole essence of in orbit service and manufacture is really about moving away from single-use, fragile spacecraft and towards a future economy where we are refueling spacecraft, we are maintaining them in orbit, we are upgrading them, perhaps reusing them, repurposing them after their initial design life, bringing things back down to Earth that were created in the zero-G environment of space and so on. Central to almost all of those activities is close proximity operations, and of course that is very strongly linked to active debris removal. Most active debris removal techniques involve coming close to, grabbing a hold of, and interacting with spacecraft. So there's a lot of common ground here between the if you like, economically positive ambition of in-orbit service and manufacture and the slightly clean-up sort of necessity of active debris removal. And these things are technically complex, but they're also made more challenging by the political and regulatory context in which they occur. We have a notion of launching nations in the space sector globally. That was a concept that was developed during an age when individual nations were doing their own thing in space and rarely interacting. We've moved beyond that already, I feel, but in particular, I think over the next few years and next decades, that will come to look really quite obsolete. A single launching nation as a concept is no longer really applicable to most missions. And that sits alongside the context of both preventing and curing the debris problem that we have, which Bruno referred to as well. So where I want to sort of draw a few perhaps helpful analogies here, just very briefly, is drop in a few suggestions for actions that we might be able to carry forward. So at the moment, it's actually quite hard to do the right thing in terms of deorbiting junk in orbit. If we consider approaching an object which is broken, no longer functioning, even if you had the finance to undertake the mission, it's not clear that you would have the permission to undertake the mission, particularly given the multiple launching nations context. So at present, we have a system where consent is necessary to be sought. The answer is no by default. You can't remove a piece of debris, somebody owns it. Perhaps in future we can move to a model where consent is given by default, a kind of opt-out approach, where if there's a piece of debris in orbit, then common agreement is that you are empowered to go and remove it, unless somebody says that they specifically want to protect it. So that's an example of just making doing the right thing easier. In the aviation world, tracking, information sharing, tracking aids, these are the norm for civil aviation over international airspace. Everyone is benefiting and has done for many years. They're not the norm in spacecraft operations, although information sharing is becoming more common spread. But even now, a few spacecraft carry tracking aids, either active transponders or passive devices. And that seems like a relatively straightforward thing to start to bring in as an international norm to just make it easier to know what's there, to know where it is, and to know if there's a hazard situation developing. And down to the oceans, well, if you consider that one well-run, diligently operated fishing ship in a fishing area is not a problem. You can take 1,000 well-run, considerate fishing ships, put them in the same fishing area, and it is a problem. So simply asking people to behave responsibly is not sufficient to solve the problem. It's necessary to share equitably the resources that are there and manage these finite resources. And in the case of low Earth orbit, the space itself, the available orbits are the finite resource, just as fish are in the fishing grounds. And when it's out because your time is up, then you need to leave the space as clean as you found it, really. Now, these are principles that, in essence, have been operating in the geo belt for space for many years, and I think we now need to consider whether this approach needs to be rolled out into low Earth orbit. So that's all I wanted to say in my presentation. I'll just go over those slides there, and I'll hand back to the floor.
Thanks, Richard, for that very interesting presentation, and also for providing some interesting insights and thoughts that are connected also to the previous session, which was more focused on observational aspects. So that's also very, very helpful insight. So we now move back to Space Agency, in this case to ESA, and I think it's Tiago who's here in the panel. I have to admit I cannot see who's actually there on my screen, but I believe it's Tiago.
Hello, Manuel.
So, hi Tiago, good to see you.
Hi.
So you joined ESA, I believe, in 2007 already as an assistant system engineer at ESA's concurrent design facility in Aztec. And many of you know you have been involved in ESA's Clean Space Initiative since then, or since 2009, around that time. And actually, the Clean Space Initiative, it also became part of ESA's agenda 2012 to 2015 as one of the 10 agency priorities. So you're obviously involved in a very prominent activity that is undertaken by ESA. So please, Tiago, the floor is yours.
Thank you. I'll try to share my screen. Okay, can you see my screen? I'll assume yes. So
yeah.
Good afternoon, everybody. Thanks for inviting ESA and me for this this conference. I'll try to give a holistic perspective of what we have been doing in ESA and the challenges we are facing as well when we talk about ADR and iOS, and what are our perspectives also for the future. To start, I would like to mention, because I think it's an interesting part of the puzzle for us. Definitely looking ahead and trying to map what we need to do to achieve space sustainability and the sustainable use of space. It has become very clear to us that it is necessary to develop safe and affordable active debris removal in order to be able to maintain the orbits in a sustainable under the sustainable threshold and being able to operate there in the longer term. This for us also means that moving ahead, it would be important to develop an in-orbit servicing ecosystem that can sustain both ADR but also other services and move on towards something more in the future. So you may have heard about the Zero Debris Charter. This is our attempt to map what needs to be done urgently and what, as an industry, we should try to achieve by 2030. Looking ahead, our vision is to use this also as a stepping stone towards having a more circular economy in space. And I'll try to give you some insights on what we are doing in this direction. So one of the first challenges that everyone has to face when we talk about active debris removal or in-orbit servicing is, of course, technology. Where are we with technology? And the developments take time. Not only they take time, but also the verification of them is fundamental. And for some of these equipments or technologies, it is key that they are actually eventually demonstrated in orbit. One of the points that always comes up when we talk about active debris removal or in-orbit servicing are the interfaces and the fact that having more standardized interfaces, either for removal or for other services, would be a key element, let's say, to develop a future market as well in this area. We have been doing some work on this. There's also work outside of ESA, of course. I'm just mentioning here some of the interfaces that we have developed and that will be on board of future ESA satellites, and that will make or try to render active debris removal safer and also cheaper. That's the intention of these developments. But as I say, there is a need in the end to demonstrate several of these developments in orbit, so to guarantee this safe aspect that is behind the logic that we need to apply for active debris removal. Another important element is, of course, guidelines and best practices. We are starting to see also, as Bruno showed, flourishing industry behind in-orbit servicing. It will be important to capture these lessons learned, these best practices, and to be able to share. We believe this is another key element, again, more on the technical realm, but to enable safe close proximity operations and in-orbit servicing in the future. And this is another element that I believe needs to be pushed in the future. Finally, as I say, in the end, we rely on having these technologies, these processes demonstrated in orbit. In ESA, we have been promoting a number of different missions in different fields of what we embark in this active debris removal and IOS program, being it removal of debris, but also in-space transportation activities, inspection, and AOCS takeover for lifetime extension. So they're all missions that are started to that have been in development or that are starting to be developed. But we are now starting also to prepare the next step, as I say, that was going towards this circular economy and having a perspective on that. And I can tell you that from the technical point of view, and in several discussions we had in the past, even activities with different companies in the sector, it is not an easy step. It changes the logic in which we operate. It changes the logic in which a service is provided. So far, satellites are designed to be used once. They're eventually transported by external servicer, but when we start to replace parts, to repurpose, for example, or refueling or recycling, we are talking about a really change of mindset on the way we operate, on the way we manage legally as well the assets, but also on how we design. And if we ask people to get out of their line of thoughts that have been the basis of the space sector for many, many years, and start thinking, what would it be? What would it be space if we could actually assemble recycle things in orbit. It's not so easy, and it will take a lot of innovation and a lot of work to get our minds around this problem. So we have started already in 2019 looking at this through different initiatives. One of them was the on-orbit manufacturing, assembly, and recycling, OMAR, we called it. This has given us quite a bit of know-how. We collected, or we tried to put together also industrial and commercial know-how this year at the Clean Space Industry Days. And the result of this is a white paper that will be published in the coming weeks. So that will be accessible to everybody. And this will be the starting point for something else where we expect in the first quarter of next year to have a call for ideas about how to make or how to promote a circular economy in space and to try to design key missions, key building blocks that will be enabling this possibility, this future way of doing space. And we plan to have a number of activities coming out of that in the coming years. So we expect that this will also start paving the way for this more longer term perspective when it comes to space sustainability and the use of the orbits. So this is my presentation. Join now for the panel.
Thank you very much, Tiago. Okay, so with this, we have ended our round of introduction speaks, and I would like to invite all the panelists to join us now on the virtual podium. As I said, I cannot see any information, so maybe Ines, you can also support us if there are questions from the audience. But I would like to start off with one question. Tiago, you just mentioned in the topic future space circular economy. And I was just wondering in terms of space environment management, a term that was used in the previous session by Thomas Schildknecht. So in terms of space environment management, do you believe that in-orbit servicing is really the next big step after we have long discussed about space debris mitigation and now, I mean, the next topic is the topic of space traffic coordination. So to all the panelists and maybe also, first of all, to industry or to Bruno or Richard, do you believe that in-orbit servicing is the next big step?
Well, you have to go, Bruno.
I think that I'm a bit confused with who the question addressed to you, Tiago. I don't know. I can give it a go. I would also know in terms of the big step. I think we need to understand how to avoid it even before we start to actually collect it, because there are other issues to just go and fetch them, which can actually generate or create even more problems than mitigate them. I think from an active debris removal, just for the sake of bringing stuff down, it's great. I think we need to understand is what could be done with this debris that is up there. So thinking about the next step in terms of the recycling, as Tiago was mentioning, and I also think it's something the industry is looking at, not just from the manufacturing perspective, as Richard alluded to, in terms of bringing stuff down to reuse, or in terms of materials that could be either manufactured in space or repurposed from other objects. So I think we're not quite there yet. I think from a cleanliness of space or sustainability of space perspective, and even from an industry, an operator perspective, I think we need to basically mitigate and send less stuff up there and try to what we send to be responsible and conscious that we can clean up after ourselves. So I think that's the key message. It's also a timeline issue, right? In terms of the technologies that they're developed, which are not quite mature yet to enable that in full scale. So the services that we could put in place for that to happen are not quite mature. And then there's the economics of it, which is a circle that we have not squared yet. So it's it's something that from an industry perspective, we obviously need to make money, and for this to be sustainable, needs to be maintainable as a service to go forward. If we do one mission and then we go bankrupt, that's obviously not the intention.
Thanks. Anyone else of the panelists? Maybe Richard? What are your thoughts?
Yeah, I'm happy to offer a view here. So my own feeling is that in-orbit service manufacture is coming. Quite confident in that view. I think perhaps the way in which it will come about is maybe not quite what most people imagine. In almost all areas of space technology development, the first steps have been taken by nation states acting in their own national interests. I think that's true of launch technology, it's true of Earth observation technology, of communication technology, of navigation systems. All of these things have been driven by strategic national interest. And whilst much of the focus of attention around IOSM is around the commercial applications, I think we have to be aware that all of the things that we imagine we might do for commercial services also have applications in the sphere of national security and defence. And these are areas that I think, ready or not, nations are going to start looking into these capabilities and pushing them forward, and that will drive capability, and those capabilities will subsequently find application and growth in the commercial world. But I think we can't afford to just imagine it will be a commercially driven only context here. IOSM is going to change the way space is used.
Yes, thanks for sharing that thought. Yeah, please. Go ahead, Thiago.
No, I was going to continue in that line, but basically to say that I think one does not replace the other. But the question after we try, and that's the first goal guarantee, the sustainability of space operations, is how do we best use the resources, and how do we best use the resources that are also already in orbit? I mean, we have to think, of course, that for every kilo we put in orbit, there are more than 100 that will probably stay on ground. In some cases they are used, some cases not. So there is also that part. And to say, I think different solutions may be needed in different orbital regions or for different systems. And I think all of it makes part of a long-term solution where I believe, and I think it's what Richard is also saying, there will be more systems, more space, more activity. And we need to find the right solutions for the different activities we are talking about.
Yeah, I also would like to add, and I found it very interesting what Bruno and Richard shared with us. I would fully agree that the main priority should stay on preventing the creation of space debris. Because in things like ISO and IADC, we realize the situation in space, more and more launch traffic, more and more space debris, and we are discussing more demanding requirements to handle these problems. And there is a tendency that you see the increasing effort that you have to undergo in space missions to cope with these problems, and there is the tendency, okay, we might have ADR and in-orbit surfacing in a few years, and we could shift just the effort away from the satellites to future services. I think that is a way that we should go, but there should be also a constant effort to prevent space debris mitigation. And in addition to that, to cope with the increasing problem, we for sure need techniques like ADR to get rid of space object launched decades ago that could potentially explode in the near future and pollute orbital regions. And we we should think about solutions for that. Keep clean for future missions and try to get rid of the stuff from previous generations. And there, I think ADR and in particular ADR could be of great help.
Yeah, thanks for sharing these thoughts. Which brings me to another point. Jan, you mentioned that spacecraft should be designed to be maintained, and also Tiago mentioned the same topic with these standardized interfaces. So, do you think this is the way to promote these kinds of technologies also for commercial use? And I mean, we can do it on agency side, for example, make this a requirement, but what would be needed to promote these technologies also on commercial spacecraft? Maybe Jan or Tiago, you can start.
Well, maybe I can start then. Well, I think for the commercial sides, the way I see it happening, for sure there is some public attention that is being given to sustainability, and especially for large constellations, for example, there is for sure a concern to show that they're being conscious. And in that sense, we have seen some of them already adopting, for example, interfaces that could help the removal. So there is this aspect. There is also, of course, the aspect of regulation and standards and the evolution of them. As you said, Manuel, the agencies can also have an active role on both making the technology available, but also making standards and eventually applying them on their own missions that will make the recurrent use of them more easy. And then there is, of course, the aspect, and this is maybe where also iOS can play a role, even if it can be used for removal. Some of the same interfaces could also be used for lifetime extension or other services that are also commercially interesting for commercial missions. So I think there are all these routes to explore. In any case, I think the important part is really to de-risk if we need to remove the object in orbit in case it fails to the orbit itself, let's say.
Yeah, I would like to add on this and maybe point to a chicken and egg problem that we had, and would also like to take the opportunity that we have industry here in the panel. We already have a standard on ISO level 24330 on guiding principles regarding remote proximity operation, rendezvous proximity operation, and in-orbit servicing. But we've for now left out any technical t-shirts. So we do not have technical standards. And we have to be technology agnostic in our standards. So it's at this current state, it's very hard to anticipate dedicated technical solutions. And I wonder what actually is the need from industry. What would you wish from ISO or IDC or whatever, whomever? What do you need in with respect to standardization? Could you answer, Bruno or Richard?
Let me try. I think I'm close to the industry, Richard, probably. So the standards you mentioned, Ian, I think actually great. I mean, from an operational perspective, that we are basing our missions on some of them, and I think we've contributed actually actively for a lot of those discussions. I think from an interface, the problem is being solved, and it's kind of been solved from the very onset. As soon as the big spacecraft are launched with a spacecraft with a launcher interface, be it a ring, an adapter, whatever. So that is kind of known, and that's the initial interfaces that I think the industry is looking at. Now, if you're targeting things that are small that you're launching in the future, obviously having new targets which are standardized that you can grab, or that you can grapple, or all these interfaces, big magnetic or plates, targets, beacons, all of these things are useful. And I think the industry will follow. It's a bit like the the USB-C, right? So the interface on your phone. I mean, the industry will follow that because it makes the life for the industry easier from an interface perspective. It makes it cheaper because, you know, scalability in terms of the production of those devices, it drops if you're producing more than one, because if you only do a prototype and then that standard doesn't work or that prototype doesn't work, you need to redo it again, qualify it again, and so on and so forth. So from an industry's perspective, the standardization is always welcome, particularly from a scalability point of view, so that we can target customers that are not originally known to us because they adopt that standard, and obviously it makes sense for us to potentially address that market. So the answer is yes, those standards are welcome, and we would, you know, be happy to provide contributions for those discussions.
Perhaps just to add on the end of that, I certainly, you know, recognising the technical challenges around standards, you know, that's one aspect of it. But I think what we see is also that many of the organisations involved in close proximity operations and docking, refuelling, debris removal, one of the primary challenges they face is actually non-technical. It's getting agreements through licensing regimes. It's getting agreements across borders. You know, if you have a spacecraft commissioned from an Italian organisation built by Surrey Satellites, launched on an American launcher and operated out of Germany, you know, whose permission do you need in order to approach that object and interact with it? And while you're doing that, which organisations are bearing the commercial liabilities for any damage that they might cause? So these things are, you know, being addressed in missions, but at the moment it's you know, I think it's taking an unsustainable amount of effort from organisations to overcome these challenges, and somehow we need to find a way of regularising how these interactions are done across different national systems so that it becomes routine.
I think we also need to. That. Sorry, I was just saying, I think we need to make a big distinction between the in-orbit servicing and the active debris removal, although the technologies to address those could potentially be the same. I think from a business perspective, they're completely different. I mean, we can adapt to the in-orbit servicing. We can build a business case around a specific customer or specific target. Active debris removal has a different business model, business case, which will then influence the not just the technical solution, but also the liability and the discussion around that. And that is an important distinction that needs to be done. Although, as I said, some of those technologies are going to be very similar. It's a different problem from an industry perspective as well.
Yeah, thanks for that. I think my connection is also a little bit delayed. But given the time, I wanted to make use of what you just said, both Bruno and Richard. I mean, this is a UN Portugal conference on management of and sustainability of outer space activities. So what do you believe is the next pressing point to be done on level of United Nations to allow in-orbit servicing and active debris removal to develop further? I mean, you already mentioned a few of the points, but maybe you can elaborate a little bit more on that. What you believe is needed on international level?
Well, perhaps if I start there. So, I mean, a couple of these points I've alluded to in the presentation I gave earlier. I think one of the things that has now is becoming obsolete is the original conception of the launching nation within the UN framework. So, you know, that has its origin in a time when it really was a single nation with a single-use spacecraft, and we're already beyond the single launching nation element of that. The single-use spacecraft has found its time already in the sense that the International Space Station was an exercise in bringing multiple units together, albeit at the level of nation-state interaction, and so they were able to find a way through. But for the poor commercial actor who tries to do the same thing, obviously it's much more complicated. So I think we do need to address that principle. Perhaps there's a mechanism where nations who are in some sense attached to a nation to a mission because they had some role in its launch might be able to rescind their stake in it if another nation is prepared to take it on. I'm not sure if there is a mechanism for that to happen at present. If you weren't sure which of 4 nations were considered the launching nation, I don't think there is a mechanism by which those 4 nations can agree that one of them will carry the responsibility for it. So perhaps that's something at the UN level, and also the notion, as previously mentioned, around management of quotas and slots. We've been managing GEO in a certain way for many years because it was immediately recognised as being a limited resource. Well, we are now recognising LEO as a limited resource, and so similar approaches could be taken.
Yeah, very interesting ideas. Maybe Bruno, you want to compliment from industry side?
I mean, from an industry perspective, I'm not a fan of quotas, of course, but obviously this is something that needs to be. I understand the relevance of this discussion, and in terms of trying to get the framework in place to operate safely, and I think this is really where the UN can help. My fear is the timescale for this, because we're already doing this, and the UN is playing catch up with all these things. And it's not UN's fault; it's the whole framework of the agreements and the arrangements that need to be put in place. So, in order to even agree to move forward towards a direction, it takes a bit of time. And I'm glad these discussions are happening and these initiatives are happening so that we can move forward. But I think that's UN's role, is trying to get their international coordination in place. So what Richard was mentioning about the liability is really important, and I think we also need to address that. I mean, we have companies now that are probably worth more than a few states, and these companies are actually operating in the space domain anyway. So it's a matter of how we transfer liability also from the states to the companies. Which is also relevant. Otherwise, you're going to find ourselves in a situation like in the shipping industry, where you have flags of convenience, which is also not something that we want to do. But the industry will follow that if pushed in that direction, because it will find the loopholes to enable that. So currently, we are operating in a big loophole, all of us. We want to close those loopholes, but in a way that is also commercially viable, so the business case allows us to continue to do our business.
Yes, thanks, Bruno. Maybe Jan, do you want to comment from the perspective of the National Space Agency?
Yeah, of course. It was already a couple of times mentioned that space is a limited resource. We share this space as a limited resource, and we should also share the burden to ensure that we can use space sustainable, and that future generations can make use of space as we do. And I think that's the main role of UN to ensure this. And we discussed the whole day the need to have more demanding requirements. And we have initiatives all around the world. For example, ESA Zero Debris initiative and the Zero Debris Charter. But we have to ensure that we have adherence all over the world to these guidelines and standards. And I think that the UN has an important role to ensure this.
Yeah, thanks. Last word to Thiago.
Thanks, Anna. No, I think most of the things that have been said, I was exactly going to also hint on the same point as Jan, that I think is important to try to reinforce the good examples. We often hear in these discussions that it is a competitive disadvantage for some countries to adopt more stricter regulation. We try to having this long-term perspective, we may actually turn it into a competitive advantage for companies and countries that are developing some some capabilities, and to promote this collaboration and, let's say, promote the good example rather than the opposite. I think it would be very important. In terms of the aspect of limited resource, I fully agree. One thing that I would like to put on the table, because we tend, I mean, now we are focusing in LEO, and as Bruno has said, we are often running, trying to catch up with what is going on. I believe that would be important to have a perspective that goes beyond just LEO and GEO, that are the hot spots right now. But we see the race for MEO coming up, and it's important that to consider that any debris left in there will stay there for a very, very, very long time, if not forever. So something to consider already, I think, in the next steps.
Yes, indeed, Tiago. I think that's also a very relevant point. So with that, and also looking at the time, I think this should now conclude our session. I would like to thank all of our panelists here, so Richard, Bruno, Jan, and Tiago, for sharing your insights, for sharing your thoughts. And with that, I believe I can handle back to Ines.
Yes. Thank you very much, Manuel. Thank you to everyone. Thank you to our speakers, to our moderator, and also to our rapporteur. So for today, this will be the last session, and tomorrow we'll be back at 8 a.m. UTC for a space resources discussion. So we'll see you tomorrow. Thank you very much to everyone.